silicon dioxide nanoparticles, right? So they were getting ready to do that study. So did you know what those nanoparticles? Oh, no, we have this information from the manufacturers, and this is 50 nanometers, so they were getting ready to do that study. So I said, all right, give me some of those. So he gave me some of those particles from the manufacturer. So I got it to my own laboratory, so I asked some of the scientists in my lab. First thing they did was Raki, actually, which was one of the students from Mumbai. So I asked Raki, why don't you just put it in some buffer media and see what's happening here? The moment she put the nanoparticles in buffer media, it was all settling down. I said, it cannot be nano, because your sedimentation rate has taken over the Brownian movements here, right? Because the particles are settling down. Cannot be nano. I said, all right. Take it to the instrument and just measure it on NAN1 or NICOM or some instrument. So this is what we got. Manufacturer, 50 nanometers. Look at what we got. Now, so what happens now? So if a biological scientist does this study without characterizing these things, he goes to the site, and then he will conduct the study. He will have it and say, oh, it doesn't go to spleen, it doesn't go to liver, there's no problem of this nano, they are safe. But what did he administer? He didn't administer nano anymore. So, you end up with the wrong product, you get wrong results. Right? So pay attention to it. So those were the challenges about the science. Now, what about the challenges of crystallinity, or challenges of dissolution? So I mentioned some challenges of really looking at size. What's a good measure for size? How do you measure that? How do you evaluate that? So I don't think anybody has resolved that. That's an opportunity for some young generation to think smartly, think out of the box. Okay, so come up with some reasonably good definitions, reasonably good understanding of that. The second thing about the crystallinity, I mentioned sometimes it tends to become amorphous. I think your preparation was also amorphous, right? The chromite goes over. Products like that tend to become amorphous in nature. When you have a product, it was crystalline, they tend to be stable thermodynamically. Crystals tend to be more thermodynamically stable, and they tend to be less solid. Amorphous compounds, thermodynamically unstable. Or if you have a product in between, imperfect crystals, they are in between the amorphous and crystalline. So depending on the content of amorphous and crystalline, we might have different dissolutions. So in this case, we prepared an amorphous preparation, and in that amorphous preparation, just internally we wanted to grind it and prepare some amorphous preparation. See the dissolution here. After some time, we see the dissolution here. I don't know, but I think in just about a month, what happened to the dissolution here? It has gone down. So we looked at crystallinity. I'm sorry, it's not very clear here. Obviously, the crystallinity was changing with time. So the dissolution was going on because crystallinity was changing with time. Now, this is another molecule. I didn't write here. I think this is carbamazepine, a generic carbamazepine. So we prepared this day 0, day 1, day 2. The red one is day 1, and the green one is day 2. So if you look at some, sorry, I can't see very well. Now, just look at this region here, 27.95 take the value. So if you see the crystallinity here, just you see in 1 or 2 days what happened to crystallinity. So if you have crystallinity, that's going to come back up. If you have thermodynamically unstable system with time, they tend to become stable, and the dissolution goes down, right? Now, so does it have any consequence on bioavailability? Now you might say, well, particle size is fine, but what relevance does it have to actual clinical study, or what relevance does it have to PK? It's impossible to do PK studies on each and every aspect. There are thousands of variables, right? So this one study, this is what has relevance. Look at that. When you have crystalline compound and you have amorphous compound. Now, if you are preparing some preparations, they might have something in between